Hello, and welcome back to Catz.
Magnets go a lot further, or electromagnetic or electrostatic force goes way further in explaining, this idea of gravity than anything else.
So, in my last video, I took a look at the Globebusters team, who are a self-proclaimed team of scientific experts who claim to be able to prove that the Earth isn't a spinning ball. And I was so shocked at what I saw in the last video, at how academically weak they were and how poor their arguments were, that I had to look at other videos. And I stumbled across this one, where they claim that gravity isn't real, but instead electrostatic forces of attraction are responsible for things falling towards the Earth. Now, we might wonder where they get that from. Well, apparently it all started here.
Gravity is nothing other than dielectricity. Gravity is no different than turning on your TV set and actually shining a light off from the side and seeing little dust particles actually head to the TV set and stick to the TV set. That's why you're running your TV set, especially little CRT tubes, got so dusty. The dust in the air would go gravitate to the front of the... That is the exact same thing as gravity. People think that that is an electrostatic charge, or like you charge a balloon up and you pull someone's hair to it. That same acceleration, not force, that same acceleration is what we ignorantly call gravity.
So at this point here, it's probably relevant to explain what he's talking about. I'm going to show you this short clip, and then I'll get the whiteboard out just for 10 seconds.
Let's say the pipe has a negative electrical charge. If I bring it close to the stream of water, the water molecule flips so that the positive end is pointed towards the negatively charged pipe. Opposite charges attract, so the water is drawn towards the pipe.
So a slightly more basic analogy to explain what's going on is this. If we imagine we take a static balloon, we've rubbed it in our hair maybe, and it's full of negative electrons, negative charge, which is basically the static electricity, and I bring it towards a stream of water, the electrons in the molecules of water are pushed. They are repelled by these electrons to the back of the molecule, if you like, making the back of the molecule more negative and the front of the molecule slightly more positive. So overall, still a neutral charge, but that charge isn't evenly distributed anymore. And that gives us the effect that the front part of all those water molecules are more positive than the back part. And we can simplify that into a diagram that looks a little bit like this. But essentially, the electrons now are attracting the front part of the molecules more than they are repelling the back part of the molecules, making the water stream bend inwards towards the balloon. Now, what's that got to do with gravity? Well, what Bob Nadell is suggesting is that the Earth itself, and we'll get to why the Earth has a negative charge in a minute, the Earth itself has a negative charge. So essentially, could the Earth be doing this to all objects in the atmosphere, causing them to fall to the ground? In fact, he's not just suggesting it, he seems pretty convinced.
Wow. It doesn't take a great leap of faith or logic to then see that what Wal Thornhill was talking about the static dipole effect, attracting everything to it, that it is indeed the Earth itself that sets the potential that determines up from down. And this is it. This is actually it. It's the static potential between the ground and the sky itself.
And in fact, as the video goes on, he gets even more sure of himself.
Proving unequivocally that gravity is an electrostatic force.
Now, anybody that knows anything about gravitational fields and electric fields knows that there is literally a bucket full of ways that we could debunk this argument. I'm going to concentrate on one. You put your favourite ways in the comment section if you've got any. The one I'm going to concentrate on, and the reason I'm concentrating on it, is because it's a method that allows us to make more fun out of Bob Nadell. Let's begin.
And it doesn't matter if they're metallic, it doesn't matter if they're wood, it doesn't matter if they're plastic. Electrostatics seems to have this exact same effect on everything.
Now, Bob Nadell has to make the point that this electrostatic force has the same effect on all objects, and that is because when we measure objects falling in a vacuum, without fail, they all exhibit an acceleration of 9.8 meters per second squared. So if electrostatics didn't have the same effect on all objects, then it couldn't be the explanation that really he's trying to make it.
Here he's got a charged straw, and it's being attracted either way to his hand.
Okay, so let's just watch that first bit again. The straw is being attracted to his hand for reasons that we've just discussed. But just let's have a look at how strong we think that attraction is.
Here he's got a charged straw, and it's being attracted either way to his hand.
So yeah, it is being attracted towards his hand, which is exactly what we'd expect, but it does at times appear to be struggling to overcome some of the frictional forces between the straw and the top, which is fine. But before I show you the next clip, I've got to introduce you to metallic bonding. So, in the structure of a metal, what we find is that the nuclei, the positive nuclei, are surrounded by what we call a sea of free electrons. Now, what that means is, or what this is showing, is that essentially in a normal atom we know the electrons fly around outside the nucleus, but in metallic bonding not all of the electrons stay bound to their nucleus. Some of these electrons actually become free to move within the metal themselves. That's why metals are such good conductors. That's why electrons can flow through them. And the ones that have this ability to sort of just drift through the metal we call free or delocalized electrons. Now, why is this important? Well, if I have, let's say, a statically charged object, maybe a big negative charge down here at the bottom, these free electrons can move much more than they can, for example, in the water or in a non-conducting object. So what we get is this effect where the electrons can be pushed far further back than they can in a non-conductive material, making the front of the metal relatively far more positive than you will get in a non-conductive material. In other words, making the effect much greater. So in other words, if this experiment was going to be repeated, let's say with a metal knife, we should see that straw not struggle to overcome those forces of friction. We should see the effect being much more visible, much more powerful, therefore proving that electrostatic forces don't affect all objects in the same way. Bob, can you do that for me?
Now we've got a metallic object. I think he's got a fork there or a knife, something like that. And it's being attracted to it. So it doesn't matter if it's biological material like us or dust.
Wow, it seems like the electrostatic force of attraction between that knife and the straw is much, much greater than between the hand and the straw. Now that would mean that electrostatic forces can't be the reason things fall, because we see things fall regardless of their mass at exactly the same rate of acceleration. What do you think, Bob?
You know, it's so funny. You can have something right in front of your face and yet for some reason not see it.
Yeah, like the 15-degree drift on a ring laser gyroscope, maybe, for example. And if you don't know what I'm talking about, watch the documentary Behind the Curve. With Bob's help, it destroys flat Earth. It's brilliant. Now, I did say this video will be a very short one, but I did also say that there are literally a bucket full of ways that we could debunk this silly argument that gravity is somehow replaced by electrostatics. Please post your ideas in the comment section, and the best one, or the one that's written, maybe the funniest one, I will shout out as the winner in the next video. So there you go, an impromptu competition. I'll see you again for the next video, which will be a Baldy Shorts. And thank you to Mr. Keebler for the music you sent for me for that. It will be debuting in a couple of days. Bye-bye.